A very important feature of the delta of a portfolio is that you just have to add the delta dollar for each of the assets that you have. So say you have two bonds in your portfolio, bond 1 and bond 2, and then the first one has a delta dollar of 50, the second one has a delta dollar of 10, and then you have the number of units that you have of the first asset. Let's say you have 5 of these and you have minus 3 of the second bond, then the delta dollar of the portfolio is going to be 5 times 50, 250, and then here 3 times 10 minus 30. So the delta dollar of your portfolio is going to be 220. Now let's talk about Risk Management 101. Immunization helps large firms and institutions protect their portfolios from exposure to interest rate fluctuations. Now, using a perfect immunization strategy, firms can nearly guarantee that movements in interest rates will have virtually no impact on their portfolio value. Immunization is a risk mitigation strategy that is going to match the delta of assets and liabilities, that's the net equity, minimizing the impact of interest rates on the net worth over time. So how do they do that? They can do it the following way. They take the value of the portfolio, and this value is net of the liabilities, and they equal it to the net equity. So basically, the value of the net equity is going to be equal to all the positions that you actually have in your portfolio. And then the second thing that you're going to do is that you're going to compute the delta of your net equity given all the positions that you have in your portfolio. And at the end, what do you want to do with that? Well, what you want to do is that delta of the net equity is equal to 0. And to do that, what you're going to do is you're going to use two bonds that you're going to find in the market, basically that you can buy or sell in the market. And then you're going to take certain positions in those two bonds so that the delta of the net equity is equal to 0. And the whole idea here is also that you don't invest any extra money. Like buy or sell those bonds without investing extra money and then get the delta of your net equity equal to 0. So here we have an example. We have a liability is a 7-year zero coupon bond that has a face value of 100,000. And then the delta of this liability, so we're going to compute the delta of it, you want to immunize it, that's a word that you use, with a 3-year zero coupon bond that has a face value of 100 and a 20-year coupon bond that has a face value of 100 and an annual coupon of $5. This is the term structure with continuous compounding. So here I'm gonna do this immunization exercise. So the first thing I do is compute the value of my 3-year bond, which is 100 times e to the minus 3 year times 11.5, that's the interest rate, and that's 70.82. The 7-year liability, it's 100,000 discounted to present value, so I get 38,000. And then the 20-year bond with all the coupons and the par value. So I get a price of 38.86. Now the next thing I have to do is to compute the delta dollar for the 3-year. So this is going to be equal to 3 times, since it's a 0, I just have to compute it by multiplying it by its price divided by 100, and I get a value of 2.1247. The delta dollar of the 7, same story, it's going to be time times the present value divided by 100. So you should use here all the digits available, and we get 2720.7569. And then the delta dollar of the 20-year bond, and this one is going to be equal to 1 over 100. Here you have to do the summation from t equals 1 up to 20 of t times the PV of each one of your cash flows from t equals 1 to 20, and you're going to find that this is equal to 3.3753. Now the next thing we need to do is to set the equations so that I do a delta matching of my liabilities with the assets. So the assets are going to be these two new bonds, the 3 and the 20, and the 7-year-old is going to be the liability. So basically I need to set the value of the assets plus the value of the liabilities equal to 0.
Use the money of the assets to buy the liability.
And then the delta dollar of the assets, that's basically my two new bonds, plus the delta dollar of my liabilities also equal to 0, the delta dollar of the net equity. By setting this to 0, when interest rate change, right, the change in my portfolio is going to be equal to minus delta dollar times the change in rates. But if this thing is equal to 0, then my portfolio is going to be not sensitive to changes in interest rate. This is going to be partially true just because the delta dollar is an approximation, but that's the intuition of what we want to do. So how do we set this up? We're going to set up two equations with two unknowns. So the first equation is going to be with the value of the assets. So basically here I'm going to get 70.82. This is my 3-year bond. So how many of these do I need? Plus 38.86 times and 20. This is how many units of the 20-year bond do I need? Minus, and then here I need a minus because this is a liability. 38,867.95 equals 0. And then the second equation is going to be with the delta dollar. So it's going to be 2.1247. And how many units of this 3-year bond do I need? Plus 3.3753. And then how many units of this 20-year bond am I going to need? Minus 2,720.75 equal 0. So here I have two equations, two unknowns. You go ahead, you solve them, and you're going to find that N3 is going to be equal to 162.79, and N20 is going to be equal to 703.60. So basically, you need to purchase 3-year bond and 20-year bond. How much of each one? Of the 3-year bond, you need to purchase 162.79 times the present value, that's 70.82. You need to buy 1,529.16, and of the 20-year bond, you need to buy 703 units times the present value, which is 38.86, and that gives you 27,338.8. Note that when you add these two quantities, you get the present value of your liability, which was this 38,867. Now let's see what happens when there's a change in interest rates. So here I'm going to shift my interest rates, all of them, the 20 of them, I'm going to shift them by 10 basis points. So this is the same thing, then shift them then by 0.001. So in this case, B3, it's now going to be equal to 70.61. B7, it's going to be equal to 38,596.83, and B20 it's going to be equal to 38.52. So in this case, so now let's analyze two cases. So the first case, if no immunization. So if I haven't done any immunization, then I would be left only with B7. So the new price of B7 is 38,596. The old price before the interest rate movement, it was 38,867. So this gives me a change in my portfolio value of minus 271 point. Now, if immunization, meaning I went and I bought the 3 and the 20-year bond. So in this case, I'm going to have the N3 B3. N3 is the original one, which was 162, and B3 is the new one, plus N20 and B20, of course, the new one here, minus B7, and here the B7 is also the new one. So this I'm going to get 38,597.61 minus the B7 new is the 38,596.83. So I get a difference of just 78 cents. So compare these two values, the 271 versus the 78 cents. The 78 cents is when we did the immunization. Basically, we wanted our portfolio to be neutral to changes in interest rates, and we achieved it. We did it because our portfolio only changed 78 cents. In the other case, it changed to $171 if we hadn't done our portfolio immunization. Now let's look at a second case. We're going to assume that there's a shift in the whole term structure of 300 basis points. So basically 0.03. This is also called a uniform shift in the term structure. So in this case, B3 new is going to be equal to 64.73. B7 new is going to be equal to 31,505.75. And B20, it's gonna be equal to 30.56. Once again, if no immunization, then we would get a change in portfolio of 31,505. You have to include the decimals, I do not include it for short, minus 38,867 equals to minus 7,362.22. And if immunized, as we just did, then the difference would be 32,041.78 minus 31,505.75. Note that this is coming from B3, adding B3 and B20 with the appropriate weights. And here I get a value of 536.03. So note that if I hadn't done immunization, then my portfolio would have gone down in value by $7,000. Instead, I made 536. The goal here is not to make money. The goal here is that my portfolio is immune to changes in interest rates. And a final case is if there's a shift of minus 300 basis points, what happens in here? So without immunization, then I would get 47,950 minus 38,867 equals to 9,083. And then with immunization, I'm gonna get 48,898 minus 47,950, and this is equal to 948. So note that in this case, hadn't I immunized, I would have made money. However, this is not important because the goal of my firm, if you think the goal of Coca-Cola is not to make money by assuming interest rate risk. The goal of Coca-Cola is to make money by selling Coke. So that's the reason that we immunize, so that when the interest rates change up or down, I end up, well, in this case, I ended up with positive values, but the point is that the portfolio value is not changing by much. There's some problems with delta matching. So delta matching works really well for small interest rate changes, but not for large interest rate changes. The second problem is that it requires the rebalancing. Why? Well, because the deltas change over time. As interest rates change, then the deltas also change, so you're required to rebalance your positions. What does rebalance mean? In a previous case, it would mean to change the values of N3 and N20. That means to recompute those two equations to unknowns to get new values for N3 and N20. In the previous case, let's think what rebalancing would mean. So rebalancing would mean that when interest rates went up by 300 basis points, then the delta dollar of my securities changed. So the delta dollar of the 3-year is now 1.9418. Delta dollar of my 7 also changed. Now it's equal to 2,205.4027. And the delta dollar of the 20 is now 2.2468. So then I do again on my exercise of delta matching. And then the new N3s and N20 that I need are N3 equals to 39.27 and N20 is equal to 947.65. So you see that these two positions are very different than the ones we had before. So before we had N3 being equal to 162 and N20 700. 162, 700 and now 39,947. So that would mean that you would have to sell some N3s to reach your new position, and you would have to buy some N20s to reach your new position. So you would have to rebalance your portfolio to achieve a delta dollar of the net equity equal to 0. We can also immunize with forwards. So forwards is a really nice thing. Why? Well, because forward is basically a portfolio of two bonds, one that goes long and the other one that goes short. So the delta dollar of a forward is the delta dollar of a long bond minus the delta dollar of a short bond. If we're going to do risk management with a bond, then we use the existing delta dollar of our position, and this one we're going to call it delta dollar before, and then we look the delta that we want after, so that we can pick the number of forwards that we need. So here the delta dollar after, normally we want this to be equal to 0, and then we have here the delta dollar before, so this would be the delta dollar of our liabilities plus n times the delta dollar of my forward. So here I would solve the equation for n. Let's look at an example. I still have my liability, which is a 7-year bond. The price of the liability is $38,867, the delta dollar $2,720, and then I'm going to assume I have the following FRA. It's a 3-year coupon bond to be delivered at T equals 5, and it has a coupon of 10% annual, and the face value of 100. So they ask us two questions. First one is, what is the delta dollar of this FRA? And the second one is, how many forwards do I need to hedge my liability? So first, I'm going to retrieve all my interest rates. So I need 4 interest rates to be able to price my forward. This is my forward contract. So at time 0, the FRA has a PV of 0. Then in year 5, I have to pay a quantity that I didn't know. I'm going to put it as X. Year 6, 7, and 8, I'm going to receive my coupon. And then in year 8, I'm going to receive also the notional of 100. These are the interest rates according to the table. And I convert them to discount factors so that it's easier for me to work with them. So the first thing I'm going to do is I'm going to set up the equation of the PV of the FRA. So what's a PV? We know it's 0, but we also know that it's going to be equal to minus X times D5 plus 10 D6 plus 10 D7 plus 110 D8. And then I'm going to solve here for X. So I end up with X being equal to, so if you make that multiplication, you're going to end up with 44.36 over 0.5488. Hence X is going to be equal to 80.83. Now, what do I do with this 80.83? I'm going to be able to compute now the delta dollar of my FRA since I have all my cash flows. So this is going to be equal to minus 5. This is the at t equals 5 times the cash flow, 80.83. Notice that this minus comes from the fact that this 80.83 is a negative cash flow times d5 and then plus 10 d6 times 6. Actually, plus now it will be 7, that's the time, plus the cash flow, that's 10 d7 plus 8 times 110 d8. And then all this over 100, and I end up with a value of 1.2. Now, I want to compute the delta dollar after for my net equity. I want it to be equal to 0, and so according to the equation is delta before, which is a liability, 2,720.7569 plus 1.2 times and the number of FRAs that I'm going to buy. So N of FRA is going to be equal to 2,166.73.